Today we're going to calculate force, mass, and acceleration. We're going to use the equation force equals mass times acceleration. I can calculate force, mass, and acceleration. Your starter reads, a student measures the speed of a cart as it rolls down a ramp. The student then records the data in the table below. Explain the student's data. Is the force acting on the cart balanced or unbalanced? So if you look at the location K, L, M, N, as the cart rolls down, you look at your average speed. Your speed is increasing. So if we understand we have an increasing speed, that would be an unbalanced force acting on the cart. So the speed of the cart increases as the car rolls down the ramp, therefore the forces acting on the cart are unbalanced. For your practice, let's take some notes. Force and acceleration. The acceleration of an object depends on the mass of the object and the amount of the force applied. It relates directly to the formula net force equals mass times acceleration. If the force remains constant, so if our push or our pull is the same amount in newtons, the smaller masses will have a greater acceleration compared to a large mass. So put into your own words, if the forces, the push or the pull, are the same on an object and the mass of the object is small, the object's going to have a great acceleration. If the forces are kept constant, so we're using the same push or pull, and the mass of our object is large, we're going to have a small acceleration. If the forces remain constant, so if your push and your pull is the same, larger masses will have less acceleration compared to smaller masses. Mass, force, and acceleration. So if the force applied to the cart is the same, the acceleration of the empty cart is greater than the acceleration of a loaded cart. So here he's giving the same amount of push to the cart. If the mass of the cart is less, he's going to have a great acceleration. So here, giving the same push to the cart, if the mass is large, he's going to have a small acceleration. Star test question. The same amount of force is used to push the carts. Which cart would have the greatest change in acceleration? So here you look at the cart that has the smallest mass. And here it's hard to see, this one's 15 kilograms and this is 25. So the cart with the less mass is going to have the greater acceleration if our forces are the same, if our push or pulls are the same. So looking at the mass, 10 kilograms here has the smallest mass, so this one would have the greatest acceleration. Try not to get confused by what they're putting into the cart, because that could throw you off if you're not reading the mass in kilograms underneath. Let's take some notes. How would we calculate force? So force, newtons. Forces are always measured in newtons. Mass is kilograms, and acceleration is meters per second squared. So in order to calculate force, we have a formula that's given on our STAR reference guide. It's force equals mass times acceleration. So I want to teach you guys how to use this formula triangle. So you would put a triangle on your paper and you would make a T inside the triangle. to place this formula inside the triangle, you read your formula, mass times acceleration. Mass and acceleration always goes across, okay? And force is always going to go up. So let me get my web paint to show you that multiplication in your triangle is always going to go across, and division is always going to go up and down. So think of this as a division sign here. So if I wanted to calculate force, what you would do is you'd cover up force so you can't see it and read what's in the triangle. It reads mass times acceleration. Okay, well, how would we calculate mass? So in order to find the formula for mass, you would use your formula triangle. So let me get my web paint again. And don't forget that what you would need to do, you'd have to put force equals mass times acceleration inside your formula triangle. So multiplication always goes across and division goes up and down. So you would read this formula to yourself, mass times acceleration, so your m would be placed here, times acceleration. Okay, and then force goes up top. So if you need to calculate mass, what you would do is you would cover up your mass and read the formula triangle. So your formula triangle reads force divided by acceleration. So that would be your formula for mass. Again, you would use this triangle to find a formula for either variable. Okay, and you do that by placing your net force equals mass times acceleration into the triangle and covering up that variable you're solving for. Okay, how would we calculate acceleration? We would take the same strategy. We'd have to get force equals mass times acceleration into our formula triangle. So you would draw that triangle, you would make a T, and you know multiplication always goes across and division goes up and down. So you would read the formula that you're given and put it into the triangle. It reads force equals mass times acceleration. So you'd put mass times acceleration. Now you can calculate any variable you need, and here it's asking you to calculate for acceleration. So let's cover up the A, and your formula reads force divided by mass. So your formula is acceleration equals force divided by mass. Okay, we're going to do a guess practice using net force equals mass times acceleration. The key to these physics problems is looking at your units after a number. So any number that has an n after it would be your force for newtons. Any number with a kg after it is telling you that's the number for mass. And any number that has meters per second squared after it is your number for acceleration. Okay, so here is our first physics problem. I'm going to minimize it just a little bit to use my tool to write. Let me see if I can move that somewhere else. Okay, good enough. So we're going to calculate force, mass, and acceleration using a guess strategy. So GUESS is going to be a strategy we can use in physics. So you may use your calculator to complete the problems. To use your calculator, you guys are going to go to your home page, and on your home page you have a calculator that you can use. Let me see where it would be on mine. So it would be the Demos calculator. So get in the practice of using this calculator, because this is the calculator that you would be using for your STAR test and your CDB. In science, we only need a 4-function calculator. So you would press that button and then you can do any of your math problems here. So I will leave this up for practice. I will use the Demos calculator during today's lesson. Okay, so here's our first question. How much force is required to accelerate a 2 kilogram mass at 3 meters per second squared? The force required is blank newtons. So to use the guess strategy, G stands for given. What information is given here? So our mass is given with 2 kilograms, and our acceleration is given with 3 meters per second squared. Now, I knew that this was my mass because I'm looking at the units. Okay, remember, kg is your units for mass, meters per second squared is your acceleration, and newtons are for force. So that's what's given. What is your unknown? Our unknown is our force, our F. So what is the equation we're going to use? Force equals mass times acceleration. Then we're going to substitute our numbers in. Force equals mass times acceleration. And then we're going to solve the equation. Our net force equals 6 newtons. Okay, and then you are going to use a griddable to grid your answers. So in order to grid 6 newtons, I'm going to write 6 and go all the way down and grid bubble in completely. And then the same for my 2 zeros. Let's calculate force, mass, and acceleration using the guess strategy. We can use our calculator as well. How much force is required to accelerate 12 kilograms mass at 5 meters per second? So we're going to grab our paint, and what is given here is going to be our mass. So our mass equals 12 kilograms. And our acceleration equals 5 meters per second squared. Okay, what is unknown? Our unknown is our force. What is our equation? We're going to use the equation net force equals mass times acceleration. Now we're going to substitute our numbers in. Net force equals mass, which is 12, times our acceleration. Our acceleration is 5. So 5 times 12 is 60. We have 60 newtons of force. Okay, let's calculate force, mass, and acceleration using the guess strategy. How much force is required to accelerate a 12 kilogram mass at 5 meters per second squared? So we want to look at what information is given. So here I'm looking at the units after the number. So if I see kg, I understand that's my mass. So my mass is given. It's 12 kilograms. And 5 meters per second squared, the meters per second squared is acceleration. So my acceleration is also given. then what is my unknown? My unknown is how much force. So those are my newtons, right? That's what I'm trying to calculate. That's my unknown. It's a question mark. So let's make our equation now. What equation is used to solve this problem? So we're going to use the equation net force equals mass times acceleration. So now we're going to substitute in our numbers for that equation. So force equals, my mass is 12 kilograms. And I like to put my numbers in parentheses when I multiply. So 12 times my acceleration, which is 5. Okay. If I multiply that, my answer, 12 times 5, is 60. So my net force is 60 newtons. Okay, and then we bubbled in, we gridded 60 newtons. So what we want to do is so in order to grid 60, we would put our 6 and our 0 here, and then 2 zeros after. So you want to make sure you totally fill in 6 and you fill in your zeros. Okay, so that's how we would grid 60 on our exams. So number 2, let's make some calculations. What is the mass of a bowling ball if it requires a force of 9 newtons to accelerate the ball at a rate of 15 meters per second squared? So let's use our guess strategy. What's given? So I'm looking at numbers, and I see my force is given because my unit here is an N. So my force equals 9 newtons. That's one thing that's given. And then here I'm looking at my units after the number, and I have meters per second squared. So this is my acceleration. So my acceleration equals 15 meters per second squared. Okay, and then what is my unknown? We're looking for the mass of the bowling ball. So I'm just going to put an M here and see if I can make a question mark. Okay, so my equation that I'm going to use, so this is where the formula triangle comes in. So earlier I was explaining how to draw that formula triangle. So on your paper you can just make a little triangle, put a T inside of it. Remember, multiplication always goes across and division goes up and down. Okay, so the formula that you're always going to be given is net force equals mass times acceleration. But if we need to solve for another variable other than force, that's when this formula triangle comes in handy. So what you want to do is place this formula inside the formula triangle. So what you would do is you'd read it to yourself. It reads mass times acceleration. So your M goes here and your A goes here. Your F would just go on top. So in this situation, we're looking for the mass of the bowling ball. So if we cover up that M, look at the triangle. It reads force divided by acceleration. So our formula, our equation is going to be mass equals force divided by acceleration. That's our equation that we're going to use to solve it. And I found that using this formula triangle. Now we're going to substitute our numbers in. So mass equals, I'm looking at my net force of 9 newtons. So I'm going to put 9 divided by my acceleration, which was 15 meters per second squared. And I'm not going to put my units here because it gets a little too messy. So I have to divide 9 divided by 15. So I'm going to go to my Demos calculator, okay, and I'm going to type in 9 divided by 15. And I'm going to press here, and it shows my answer as 0.6. So going back to my slide, mass equals 0.6. Now, what are my units for mass? Remember, the units for mass is kg. So the mass of my bowling ball is 0.6 kilograms. So now I need to grid 0.6. So here, let me get my pen. Here's my decimal, so 6 would be placed here, and then I'd have a 0. Okay, you could place a 0 in front too, just to make it clear. And then you want to make sure you're bubbling your answers in below, because that's what the computer reads when you take your exam. All right, one more practice problem. Okay. So your next question reads, what is the acceleration of a softball if it has a mass of 0.5 kilograms and hits the catcher's mitt at a force of 25 newtons? So let's understand what's given in this physics problem. So I'm looking at my numbers, and I see 0.5 kg. That kg is telling me that's my mass. So I'm going to write my mass equals 0.5 kilograms. Okay, and it hits the catcher's mitt with a force of 25 newtons. Now newtons is telling me that's a force. So force equals 25 newtons. That's the information that's given in the physics problem. So what's my unknown? What am I trying to solve for? I'm trying to solve for the acceleration of the softball. So I'm just going to put acceleration with a question mark. So what is my equation for acceleration? Well, I have to use my formula triangle. So remember, you're going to make a triangle on your paper. Okay, and you're always going to be given the formula net force equals mass times acceleration. Okay, you have to get this formula into your formula triangle. So how do you know where to place the M, the A, and the F? Just read it. Mass times acceleration. Mass times acceleration goes across. Okay, and division always goes up and down. So you know your F has to go up top. Now, using this triangle, I can get a formula for acceleration. By covering up my A and looking at the triangle, it reads force divided by mass. So what's my formula? My formula is force divided by mass. So I'm going to write that. Acceleration equals force divided by mass. Okay, and my next part, what do I have to do next? I'm going to substitute my numbers in the equation. So acceleration equals, what's my net force? 25 newtons. And the mass of, what are we talking about? The softball is 0.5. Okay, so I'm going to go to my calculator, and I'm going to do 25 newtons divided by 0.5 kilograms. So 25 divided by 0.5 equals 50. So my acceleration is 50, and it's very important to put units. My units for acceleration is meters per second squared. And to grid 50, we would put our whole numbers here, 50, and then you would come down and bubble that completely in, and then add your zeros as well.